Introduction to the C.I.H. Opel motor. So you bought a new Opel GT or an Opel Manta, and now you're thinking you're going to rebuild the motor, but it seems a little different, seems a little odd, and you're not sure how to build it, and well, manuals are the manuals and they're a little old. And some things they don't cover, and one of the things they don't cover, and what we're going to really try to cover here in this part, is all the differences between early to late model motors and the different variations that happen inside of those years, because there's a lot of them, and some of them are subtle and don't matter, some of them matter a lot. So, okay, we're going to start with the timing cover. The timing cover is the first part you kind of need to build, because you cannot build the block until you have the timing cover ready to go on the block, because then you have to put the oil pan on, and then you can put the head on. This is a timing cover. Now, it's pretty simple. It's just a piece of aluminum, nothing fancy in there. The oil pump goes in here, but we'll get into that when I start showing how to build the timing cover. But I really wanted to point out were the differences in different model years. This one is one of the early ones, and this is from a carbureted motor. And you're going to see here it has a hole for the fuel pump. That, if you go to fuel injection, needs to be covered up. Or if you go to an electric fuel pump, that needs to get covered up. Also, the earlier ones do not have this regulator, and they'll have a flat plate, and they'll be 10 bolt, and I'll get to what the difference between a 10 and a 12 bolt head is in a minute. But basically, these two bolt holes here would not exist on a very early 10 bolt cover. And also, the 10 bolt covers are a little shorter here, like we're talking a millimeter shorter. So if you don't do a little prep on that, you can actually get an oil leak if you don't do it properly. This one here is a 75. This is for the early fuel injection. As you can see, no fuel pump. And it also has a little pointer so you can actually set and do a timing light mark on your pulley, which is the only one I've found so far that actually does that. This is a 2.2. 2.2, just like the other one, but its difference is that it had a port here that's not used for anything that I know of, other than some diagnostic on the 2.2 fuel injection, as I've been told. I've not seen that, so I'm not exactly sure on what it's for, but it's not for the fuel injection itself because there's nothing that goes there. But on the 2.4 cover, which is special, there is. And there's a crank sensor that goes in here that's required for the 2.4 fuel injection. That is why this one is a little bit more special than the other ones. That said, you can still put the crank sensor on one of these other ones. It's just not going to be quite as accurate. You're still going to need to have the oil pump cover for the 2.4, which I'll show when I'm building it later. That primarily is a difference with the timing covers. Now, when you get to the heads can be a lot different. This is what we were talking about just a minute ago. This is a 10 bolt head. The 10 bolt head does not have the 11th and 12th bolts. The 10 bolt heads are different in a couple of ways. Number one way is that they have only 3 bearings, most of them. I'll get to the difference. There is one specific model that's a little unique. But most 10 bolt heads are solid lifters only. And what solid lifters mean is basically this is a solid chunk of metal that's stuck in the head. And all the rest of them are going to be using hydraulic lifters. So that makes a difference. And the kind of cam you use and some other parts of your build. This is a solid lifter, and it's a solid piece of metal. There's no moving parts. This is a hydraulic lifter, and if you push it. This basically has a spring inside, and this piece here is pumped up with oil pressure that comes through. So as you can see, this one has no hole for the oil pressure. This one does have a hole for oil to get into and lift it up. So 10 bolt heads use a different bearing, which is a little harder to get. And when you get them, most of the time they're semi-finished, which means that your machine shop is going to charge you more. And that particular head is the 19 C.I.H head, which is a nice head to have if you're trying to get a little bit more compression, but again, the bearing problem kind of makes it a wash. Now, when you're looking at the different heads, and you're looking at the 12 bolt heads and the 10 bolt heads and the 2.2, 2.4 heads, there are also some additional differences. This is what makes a 12 bolt, this is what makes a 10 bolt. These are your 10 bolts. These are your 11 and 12 bolt. Now, most 10 bolt heads, as you can see here, have 1, 2, 3 cam bearings. 12 bolt heads have 1, 2, 3, 4 cam bearings. inside this right here that actually, like this one here, this is a cam bearing. Your cams are going to ride on those. There is an exception to this rule. In the 1971 head, there is a 10-bolt 4-bearing head. And that one you can tell by, if you look here on the side, there's a number here. This is called a Delta head. It's a Delta 19A head. If you look on the 75 head over here, well, this is a 2-liter head. This says X2E. That's an XR2E head. This is an X19A head, your standard 12-bolt. Now, the 71 head will say X19, but it will be a 10-bolt head. Why this matters? These heads here have a lot more carbon on them, and as you can see, this one was cleaned by my machine shop about a year ago. It's rusty already. It doesn't look like this anymore. That's what it looks like when it came out of the machine shop. Now, these have a lot more carbon in them. They rust a little bit easier, and the other thing about them is that they also tend to crack better. The 10 bolts have more nickel in them, so they don't crack as bad and they're easier to work on. So that's what I prefer, but that's a preference more than anything else. And now here is the 12-bolt head. The 12-bolt head, here is a 2.4 head. The 2.2 and the 2.4 head have much bigger openings here. On your standard head, it's a smooth D shape. Here, you see this extra roundness here. You have a little bit extra size in the chamber. They did that because also the heads themselves are different here. If you'll notice, this pin sits lower than this pin. This pin sits lower than this pin, and these ports are higher than these ports. So that's what makes a 1.9 head, or the low port head, different from the high port head from the 2.2 and the 2.4. So, here you go.
Okay, so...
And then over here you can see that one's missing.
I don't know what that means, but okay.
When I'm talking about 3-bearing versus 4-bearing heads, where there's 4 bearings, 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3. There's no 4.
Okay.
See, that one's missing. And that's what these ports are actually where the bearings get fed oil from.
Okay.
They're alignment ports. So basically, and I'll show that later on this head, because this head has them on. And this is going to be something I'm talking about when I do the build, which is when they get their motors redone. They need to get these little 8mm plugs made. And of course, now we have the block. Now, one of the main differences with the blocks, there is so many different ways you can deal with the pistons and the rods and the cranks. But what is different about the Opel motor is, as we mentioned with the cam and head, is that as you saw with these, the heads here, I mentioned the fact that we have cams, and we mentioned 3 or 4 cams in the head. Most engines do not have their cam in their head. They have their cam on top of the head, or they have the cam in the block, and it's with push rods that come up and push the lifters. We don't have that. That's why our motor is different. That's why it's called a cam and head. So what it does do though is it makes it easy to work on the block, because our blocks are literally a crank, some rods, and some pistons and bearings. That's it. Everything else is either in the timing cover or in the head. Now, what is real different with the 2.2s and the 2.4s and the 2.3s and all the other stuff is because they did make a version of this as a diesel. That head, that block itself is actually almost a full, it's almost about a full 3 inches, 10 centimeters taller than your standard Opel block. Nobody uses it. But what we do use is we use the crank. And this is a crank out of a 2.3 diesel. Now the reason I'm showing is because what I don't have handy to show is the crank for a regular 1.9 and 2 liter. which look about the same. There's some differences, but not a huge amount of differences in there. The one big difference between the 2.2 and the 2.2, the 2.3, the 2 liter, the 1.9, all other cam in head motors, and the 2.4 is the crank. And as you can see here, we have 2 crank weights. We have 2 more crank weights. You spin it around, and we have 2 more and 2 more. We have a total, each piston has 2 counterweights. Nice and balanced design. This is only on the 2.4. All the rest of them have 2 counterweights and a counterweight on either end. That's all they have. So that's primarily the big difference that you get in these motors. There's differences in bore and stroke and things of that nature, which you can find on my website. I'll have a link on it at the bottom of the video. But other than that, that's pretty much it for